The goal of this session today is to give you an overview how you can leverage the new external messaging API in InterSystems Iris to communicate with event streaming platforms like Kafka, AWS, SQS, SNS, RabbitMQ, and others. But before we dig deeper into this, we will start with a brief discussion. What are event streaming platforms? Why are they used? And what are the common terms or basic concepts of these event streaming platforms? After this session, you should have a good understanding how you can communicate with event streaming platforms with the InterSystems Iris messaging API, which is new in InterSystems Iris 2022.1. So let's start with an overview. What are event streaming platforms? What is the concept of an event streaming platform? Well, first of all, an event streaming platform is capable to consume and to capture a huge amount or a huge stream of incoming data in a very, very high frequency. So event streaming platforms are often used in an IoT environment, Internet of Things, where you have machines which are equipped with sensors, and each of these sensors steadily sends data to somewhere. And the somewhere is the event streaming platform. The target is the event streaming platform. And the event streaming platform can consume the incoming data. But that's not all. Event streaming platforms also can react on incoming data. So an event streaming platform can notify someone if data comes in. So consider you have a machine with a sensor or with sensors, and one of these sensors reports a critical condition. Then it might be crucial that someone gets notified about this. So the event streaming platform can react on this incoming data and can notify someone who might be concerned and may fix this issue. So event streaming platforms can consume the data and can react on incoming data, send out alerts or notifications to someone. And event streaming platforms cannot just consume the data. Data needs to be further processed or analyzed. So event streaming platforms provide the incoming data for further processing for analytics. And what are the examples for these kinds of event streaming platforms are Kafka, AWS, SQS. SQS stands for Simple Queue Service. SNS stands for Simple Notification Service. So these are two services that run on the cloud, in the Amazon cloud, RabbitMQ and JEMS. And we will cover Kafka and AWS, SQS, and SNS during this session. We will see a demo later where we communicate with these platforms, with these event queues or event streaming platforms. What are the common terms that are used often in this context? Well, first of all, there is a term which is called a topic or a queue. A topic or a queue is simply a name of the place or a channel where the data is stored. So if you work with event streaming platforms, you send your data either to a topic or a queue. And some call it topic, like Kafka. If you work with Kafka, it's called a topic. If you work with a service from Amazon, like AWS SQS, then it's called queue. But basically, it's the same. It's just a name for this place where the data is stored and where the data is sent. Who sends the data? The sender of the data is often referred as a producer. And a producer can be a machine, a producer can be a human being. It's just the source of the data. And the producer sends the data to the event streaming platform. And the data itself is often referred as events or messages. But there is no limitation on the type of the data or the size of the data. You can send everything you want to an event streaming platform, to a topic or a queue. And the opposite of the producer is the consumer. Consumers read data from a topic or a queue. So the producer writes to an event streaming platform, the consumer reads from the event streaming platform. And when you work with event streaming platforms, you often see two different patterns or models. The first pattern is publish, subscribe, and the second pattern or model is polling. And what does it mean? Publish, subscribe means that consumers subscribe to one or more topics they are interested in. And if data comes in for that topic, all subscribers are automatically notified by the event streaming platform. Remember our example from the machine, from the IoT environment, where you have a machine with sensors. One of these sensors reports a critical condition. This critical condition is sent to the event streaming platform, and all consumers who have subscribed to that topic get automatically notified that something has happened, that their action is required. Publish, subscribe. An example for a publish, subscribe event streaming platform is AWS SNS, Simple Notification Service. Polling, the other pattern or the other model, polling means that the consumers have to read or poll a topic or queue for new data. So they ask the topic or the queue, is there any new data? And if there is new data, they receive the new data. And examples for this polling pattern are Kafka, for example, or AWS SQS. So both patterns are possible, and you can work with both kinds of event streaming platforms with InterSystems Iris, communicate with both kinds of event streaming platforms. So the question is, why are they used at all? And yeah, basically, they are often used, a very popular use case for an event streaming platform is the decoupling of producers and consumers. So you want to break apart your monolithic application architecture, split it into independent modules, independent services, and these independent modules and independent services have to communicate to each other. And the event streaming platform is often used as a communication layer. So some of these services generates data, send it through a topic or a queue, and another service who needs this data polls this data, polls this topic or this queue, or automatically receives a notification that new data has arrived. So it's decoupling of producers and consumers. And the other use case is high scalability. If you imagine in the IoT environments with thousands of sensors, with high frequency of incoming data, it's crucial that the event streaming platform is able to scale and to notify in real time or near time the consumers who are concerned about incoming data here. So high scalability and decoupling of producers and consumers, popular use cases for event streaming platforms. You as an InterSystems Iris developer might ask, do I really need them? And the answer is probably not. But there is a but. Nowadays, you are not alone. And it's a requirement that you are able to interact with other applications or services. So you must be open, you must be interoperable. And some of these external services or applications might run on the cloud, others on-prem. And you also are required to act as a consumer or a producer. So there is a need to be able to communicate with these external event streaming platforms. And to demo this, let's talk about a possible use case. And for this possible use case, let me tell you about a visit I recently had with one of my customers. I met with Joe. Joe is head of development at Great Burger & More. And Great Burger & More builds and provides an order portal for fast food items. So it's comparable to Grubhub here in the US, or Just Eat, or Takeaway, or Lieferando in parts of Europe. So you select the food category you want to have, and then you get a list of restaurants. Select a restaurant, pick the items, place the order, and the order portal sends the order to the restaurant. And Joe said to me, Michael, we have a new demand from our customers. We need to interact with more restaurants, and many of them are already in the cloud. And in addition to that, some of them use Kafka, others use AWS SQS, so event streaming platforms. And Michael, do we have a chance to communicate with them in an easy way from InterSystems Iris? You know, our Iris-based portal. And I said, Joe, that's not a big issue. We will see that in a minute. Joe added another requirement and said, our end users or the restaurants expect us to send a text message confirmation, an order confirmation or status update whenever a new order has been accepted or there is a change in the status, delivery starts or whatsoever. So can we do that? And we did a quick research and we found that AWS SNS, Simple Notification Service, could do that for us. We can send text messages, or you can send text messages via AWS SNS. The question is, how can I do that with InterSystems Iris or from InterSystems Iris? And I said, Joe, that's pretty simple. We will do that in a minute. But before we start, let's quickly summarize your current application architecture. And the current application architecture for our order portal looks like this. We have a couple of containers. Although containerization is not a requirement, so even if you are not using containers today, you still can use the external messaging API, of course. In this example, the application is containerized. It makes it a bit easier for me here, but containerization is not a requirement. And what we have is we have a couple of containers. We have an application entry point container. The application entry point container hosts the website, the order portal itself. Then we have a couple of order containers. The order containers are responsible for the order processing. And we have more than one here because we can scale up and scale down. It's pretty simple with containers to scale up or scale down. And we have one last persistence container, which is responsible for all the persistent stuff. So that's the database where all the data finally ends. And all these containers communicate via REST service calls. They communicate via REST. And this communication itself is managed and controlled by InterSystems API Manager. So what I suggested to Joe is we simply add another container to this architecture. I call it container for external communication. And this external communication is responsible for the communication with the event streaming platforms. So it can talk to Kafka, it can talk to AWS SQS SNS, and others. And the rest of the application is just not impacted. There's no impact for the rest of the application by this enhancement. We just add another container who does all the work for us. And the question is, how does the container do the work, or how can he communicate with the external event streaming platforms? And let's talk about the messaging API, which is new in InterSystems Iris now. That's a screenshot from the class reference. You find the excuse me, the external messaging API in the package %external. And then there's a subpackage messaging. And let's take a closer look. Let's take a closer look. My mouse pointer. Let's take a closer look to the classes. It's a bit tricky because I don't see here we are. So I have to log into my iris class reference. So what you see here is the package percent external. If I expand it, I get a subpackage messaging, and then you see a bunch of classes here. And the classes you see here is a generic client class. We take a look into this in a minute. And you see some more specific classes. JMS message, JMS client, JMS settings. The same for Kafka. Kafka client, Kafka message, Kafka settings, etc. SNS client, SQS client. So we provide specific classes for all these event streaming platforms. And you use the generic client class to create all the instances for the specific classes or event streaming platforms. The generic class contains a couple of base methods, like receive message or send message, and it has a couple of factory methods, which you can use to create some more specific client objects to communicate with event streaming platforms. And let's see it in action. How does this look if we try it, or if we use yeah, the issue is that I don't see, here's my mouse. So I think that's easier to leave the presentation mode, yeah. Thanks, Stefan. So let's go to my machine here. I have to log in, and I have is this readable? It's readable, okay, then let's work from here. So what you see here is the order portal. You see, unfortunately, I only can provide 2 items, German currywurst and a pizza salami. What else do I have here? I have local Kafka installation here. We have I try to change the resolution. Give me a second, please. So it's an Ubuntu VM, that's correct. So I hope that's better. So we have a generic Kafka consumer client here. So I have a local Kafka installation, a local Kafka instance, and that's a generic Kafka consumer. When you install Kafka or when you download Kafka, you get all these generic consumers and producers. And that is pretty simple here. This generic Kafka consumer listens to a topic with the name GS2022-events. So I've created topic GS2022-events. That's all the trick here. And the idea is, when we place an order, that this generic Kafka consumer displays the incoming order. What else do we have? We have a little bit more. We also have an SQS queue. That's the AWS management portal. And I already switched to the management page for the simple queue service. What you see is that my queue is located in Frankfurt in Germany. So it's across the Atlantic. And the name of the queue is GS 2022-Seattle. And the idea is we send the order also to Frankfurt. I'm not sure if it is worth to wait for a pizza which is delivered from Frankfurt, but it should work. So let's get started. Any volunteer? Stefan, did you have lunch? No. German currywurst or pizza salami? You take the currywurst. Okay. So 1 currywurst. I add it to the cart. Item added to shopping cart. I switch to my cart. I see my German currywurst. And now I have to check out. It's Stefan. 1 Memorial Drive in Cambridge. So, and in addition to that, we want to send a text message to Stefan's mobile so that he is sure that his order has been received. My Amazon settings are or only allow sending SMS text messages to German mobile numbers. So that's the reason why we have to use a German mobile number here. I click Order Now. This takes a while. The way to Frankfurt is far, and we only have a limited bandwidth here with the internet connection, but now it says order is completed. Stefan already got his order confirmation on his mobile phone. But what's about Kafka? What does our Kafka consumer say? Wow. What you see here is a JSON message. I just forwarded the JSON message to Kafka. But you see, it's Stefan, it's from the 1 Memorial Drive in Cambridge, and Stefan wants to have 1 German currywurst. So Kafka has received the order. What's about our AWS SQS queue? Let's refresh. You see, before we sent the order, there was no message available in that queue. So let's refresh. Wow, 1 message. Let's select the queue, and AWS SQS follows the polling pattern. So I have to say send and receive messages, and here poll for messages. And then we see the message here. If we click on it, we see Stefan, 1 Memorial Drive, 1 currywurst. So we have sent the order both to Kafka and to AWS SQS, and Stefan also received his order confirmation via text message. How was this achieved? Let's take a quick look into the code. What I've done is I've created a couple of classes. So I've created a class kafka.api. It's an abstract class. It's just a container for some methods. And the methods I've created here is create topic, delete topic, send message, and receive message. And these methods work or use or leverage the messaging API in InterSystems Iris. So let's take a closer look to receive message. The flow inside the method code is nearly identical if you work with Kafka or if you work with AWS SQS. There are only minor differences. It all starts with creating a Kafka settings object. Kafka requires some settings that are Kafka specific, for example, the Kafka server. And you can specify a group ID. You can group consumers in Kafka into logical groups. Once you have your Kafka settings object, you create the external messaging client, and you use the factory method create Kafka client. I want to communicate with Kafka. I pass my settings object to the factory method, and receive a status information back, success or failure. And the rest is pretty simple. I simply invoke the receive message method, which is provided by the Kafka client, and I pass a topic name to it, and I receive an output variable back with the message. That's polling, yeah. So let's try it. Let's see how it works from a command line. So what I have here is I'm connected to my external communication container. I'm in the namespace events. And what we do now is we use this method you just saw to receive messages from our Kafka installation. So it's class Kafka.api receive message was the name of my method. I have to pass the topic name, so GS 2022-events. The second parameter is an optional parameter for the group ID. I say we are the group GS, Global Summit. And my messages shall be stored in the M variable. So let's invoke the method. Simply disregard these warnings here. These are related to the log4j underneath. But let's check the status information. So it returns 1, which means success. So let's examine our output variable, M. Let's see. OK, I see it's a list of objects, object, and the size currently is 1. So if you have multiple messages in a Kafka topic, and you poll this topic, you get a list of messages back. Now we only have one message, so the size here is 1. Let's access the message. Warum sehe ich das nicht? Okay. Ah, that's better. So let's access the message. So I hope this is, yeah. You see, I get back a Kafka message object, and it contains the topic as a property, and it contains the value, and you see the order for the German currywurst for Stefan. So seems to work. The same is true for AWS SQS. Let's quickly take a look at that code. So we switch to the class SQS or AWS SQS API. Pretty similar to the Kafka method, and let's check the receive message method. And you see the flow is the same. I create a settings object, SQS settings. I create the specific SQS client, and then I invoke the receive method. So basically, the flow is the same as with Kafka. The difference here is that AWS, of course, requires some credentials. So I have a little helper method. We can take a look at it. I don't want to hard code my credentials in my code here, so I have a little helper method, and it's pretty simple. It just reads out the credentials file, which is located on my Ubuntu server, and returns the credentials back in a multidimensional array. And this is then used here. So we can set the access key, we can set the secret key, we can set the session token, etc. And of course the region. We are in Europe in Central 1, which is the data center in Frankfurt. So that's pretty simple and straightforward to communicate from ObjectScript with these event streaming platforms. In addition to that, I did one more step. Because my containers communicate via REST, I've added a little or small REST layer on top of my API classes. And we can take a look at that REST API. What you see here is the developer portal of InterSystems API Manager. And you see I have a couple of APIs here. We want to use the event streaming API. So it's simply a documentation or a specification for my event streaming API. On the left-hand side, you see a couple of categories. So I have endpoints for SNS, I have endpoints for SQS, and I have endpoint for Kafka. And if I expand Kafka, for example, you see that currently there are two endpoints. One receives message from a Kafka topic, and the other one sends a message to a Kafka topic. And let's try it out. I have a generic REST client here. And let's poll our Kafka topic for new messages. See, the endpoint is API Kafka get messages, and it receives the topic name in the URL. And if I invoke it now here, you see I get the order from Stefan via REST. Internally, this REST API uses the API classes you just saw, and my API classes leverage the InterSystems API for external messaging. And the same is true with SQS. So if we invoke an endpoint to receive messages from my AWS SQS queue, the queue name is GS2022-Seattle. And I get my message from SQS from Frankfurt, so it has a long way to Seattle. And AWS SQS returns also properties like a receipt handle. Here, the receipt handle is necessary if you want to delete the message via the API. So that seems to work pretty fine, and it's pretty simple, pretty easy to use the API to communicate with event streaming platforms. But we have a little bit more. Let's go back to the presentation. So as I said, this API is new in 2022.1. So the developer preview contains these API classes. You find it in package % external messaging. It contains classes for bidirectional communication with the external event streaming platforms. But we have done more. If you are using the interoperability layer of InterSystems Iris, so you build productions with business services, business operations, adapters, we also provide predefined components for the interoperability productions. So there's an adapter, inbound adapter here in this example for JMS, outbound adapter, you find message class, you find operation, you find service, so business operation, business services, and all you need to do is to add these predefined components to your production and configure the components, business service or business operation. So pretty simple, pretty straightforward. And again, this is new with InterSystems 2022.1. You find it in the package enslib, and it contains components for communication in both directions. So let's quickly wrap up what we have done. We have started with the concept of event streaming platforms. We have learned that event streaming platforms are able to consume large amount of incoming data in a very, very high frequency. We talked about the common terms like topic, queue, producer, consumer, etc. And we also have used the new messaging API, %external.messaging, on the classes in this package. That's so far for today from my side. Do you have any questions so far?
Hi. I have a remark.
Yeah.
We are using Azure Service Bus, which is by RabbitMQ protocol.
Mm-hmm.
So I don't know if Kafka is using it, but we didn't have that on previous version of Iris, like 2018 and 19.
Yeah.
So we did some work around to do it, and actually we are communicating now with Azure Service Bus directly from Iris using embedded Python.
Mm-hmm.
So in embedded Python, if someone is using Azure Service Bus, it's like 5 to 10 lines of code. You import the library, and you do it.
Yeah.
So I understand that this new messaging capabilities are from 2022, right?
Yeah. Yeah.
So if someone is not able to upgrade or something like that, there are some workarounds to do it
Sure.
differently.
Yeah, good point. Embedded Python is a good option.
And another remark for in Azure we call it publishers and subscribers. Mm-hmm. One of the topics that is why to use it is sometimes because of data governance issues. You have many sources of data in the organization, and for any publisher you can have multiple subscribers.
Mm-hmm.
So this is something very important.
Yeah, but this works with this external API as well. Yeah. Yeah. Good, thank you. Any other questions?
I have maybe more like a use case. I don't know what you think it fits, but would this be something that you could apply to, for example, like to Health Insight, where let's say you want to push out your data out of Health Insight to some other database, so you could leverage the streaming platform like this to just pump out data out of Health Insight to somewhere else?
So the question is, can I leverage this to pump out data from Health Insight and to push it into another database? I don't see this yet. I don't see that the external mesh event queue pushes the external data or the Health Insight data to send it somewhere. So if you have a producer in Health Insight which sends the data to the event streaming platform or to the notification platform, then you can distribute it.
I think I do. Well, right now it's more of a brute force approach where we're producing text files based off of post sync events that I can identify all the changes that came in. There's an intermediate table. Okay.
We share a similar experience. We use Kafka we use the interoperability layer.
Mm-hmm.
So we send the data, we wrote DTLs to push the data to Kafka, but again we wrote a custom .NET, custom Java code.
Mm-hmm. Because this was not available.
With this adapters it will be a lot easier because we can then configure our DTLs with the adapters on the service side.
Yeah. Okay. Any other questions, remarks? If you don't have questions now, but later, do not hesitate to contact me. My email address is michael.braam@intersystems.com, or connect with me via LinkedIn. You find me on LinkedIn. For now, I say thank you. Thank you for your attention. I hope it was useful. The conference is almost over. Thank you very much. Have a safe way home, and see you next time. Thank you very much.
Thank you very much.